In this work, we leverage the recent use of light field cameras to propose light field-oriented windows that enable more robust and accurate pixel comparisons than 2D spatial windows, which suffer from varying defocus blur and perspective at different depths. We first show example scene flow results and a virtual reality application for a moving hand holding a piece of paper. Our inputs are consecutive frames captured with a Litro Elam light field camera at different points in time, and we can see visualizations of the optical flow and the flow in depth. Now, we place a virtual highlight over some text on the paper and propagate this edit through the video by moving the highlight in 3D space using the calculated scene flow results. Note how the highlight correctly follows the movement of the text and correctly appears smaller as the text moves away from the camera. Next, we show an application for follow focus, with an example scene of a tennis ball that moves. We select a point on the ball in the first frame, and by calculating the scene flow between consecutive frames, we are able to automatically refocus the light field image for each frame to keep the initial point on the ball in focus. Finally, we show an application for cloth simulation. We calculate the scene flow between two consecutive frames of a moving cloth. Here are the two frames, their respective depth maps, and 3D visualizations of each frame. By interpolating our scene flow results, we can simulate the movement of the cloth as it wrinkles and folds. In conclusion, we proposed oriented light field windows, a novel, accurate, and robust method of pixel comparison using light field images. Oriented 4D light field windows represent scene points by accounting for shearing due to depth, translation for matching, and windowing. We apply oriented light field windows to compute scene flow and show state-of-the-art results.